Hello, welcome to a different kind of video. This one is not based on a particular problem. It is based on the idea of square roots. So we want to talk about those a little bit. But I've got something wrong going on here. So we'll stop. Break. Okay, so we have a different kind of video today. It's not about a specific problem. Somebody asked for a video on kind of how to find square roots. So I wanted to talk about them in general, and we'll see how that goes. So square roots are called that because it's literally kind of the root, the side of a square. So if we had a square that was 9 square inches, and we want to know how big one side is, well, it's got to be 3 inches, right? Because 3 inches by 3 inches would make for 9 squares, 9 square inches. So the square root of 16, the square root of 16 is 4, because 4 times 4 is equal to 16. So later on we've found negative numbers. So we added this idea that square root of 9 we might say is plus or minus 3, because negative 3 times negative 3 would also give us 9. Well, if we're talking about something applied, a distance can't be negative. So it's very easy to forget about those negatives. And what mathematicians try to do is, if they mean the positive square root, they'll say this. And if they mean the negative square root, they'll put the little negative on the outside. So that would be the negative 3. So, but this is not true or untrue. This is notation, which sometimes you'll hear people talk about as a convention. Okay. But if you're looking for solutions, x squared is equal to 9, it's important to remember that both of these are possible. So then for sure we want to be able to say plus or negative 3. Okay, so what about the in-between? So, well, if the square root of 9 is 3 and the square root of 16 is 4, then the square root of 10 must be something in between. So we don't know how big it is. It might not be a nice number. If we were guessing, of course, well, 10's a lot closer to 9 than it is to 16. So we're going to guess closer to 3. And to find it exactly, we'd want to think about trial and error. Okay, so let's pull up a calculator here and we can try. So we know 3 squared is 9. 3.5 squared, that turns out to be like 12 and a quarter. 3.1 squared is 9.61. That's not quite big enough. 3.2 squared, I'm going to guess, is too big. 10.24. So depending on how many digits of accuracy, we're just trying to narrow it down more and more. And I'm just using a regular calculator to come up with these numbers by multiplying the number times itself. Okay, so this is getting pretty close, right? So we'd adjust from here. It's got to be a little bigger than that. Next I might try something even as close as 3.16 squared. That's pretty close. That's within 15 thousandths. Okay, so that is one example of finding the square root in between. Okay, so let's go ahead and get rid of those. Okay, now one thing I want to mention about square roots is that it's very common mistake is to take a square root and try to break it up. Say the square root of two things added together is the square root of the one plus the square root of the other. But 9 plus 16 is 25. We know the square root of 25. That's 5. Square root of 9 is 3. Square root of 16 is 4. That's 7. Okay, so these are not equal. You can't break them up. And it makes sense because this 25, the 3 squared and the 4 squared are distributed kind of evenly all through here. So it's not going to be 3 plus 4. Right? In fact, we could draw out those squares. So if we had a square that's 3 on each side and a square that's 4 on each side, that's not even a square, kind of putting those two things together. But the area of these two things together would be 25. Avoid this. And there will be answers, there'll be distractor answers, try to get you to fall for that. Okay, so let's talk through just one more example. So how would you find the square root of 51? Well, you want to think about what's close. So 5 squared 25, 6 squared 36, 7 squared 49. Ooh, that's close. 749. 8 squared 64. It's definitely closer to the 7. So instead of starting at 7.5, I'm going to start with 7 and 1/10. And 7 and 1/10 squared. Close. So 7 and 2/10 squared. A little too big. So if I was guessing in between, is it going to be closer? That was 6/10 away. This is 8/10 away. That's actually pretty close to in the middle. So let's try in the middle. So it's guess and check, but the guessing is smart guessing. Right? We're always trying to get closer and closer to our result. And what number we picked, we can pick with experience. Okay. So what would you think? It's in between these two, right? So we can get closer and closer. Now there are some formulas for these things, but they're really quite specific and can be difficult to apply. So unless you're kind of quite familiar with them or have used them before, kind of a smart guess and check, and combine that with the answers that are on the test to eliminate possibilities, and then you're set, right? So if you're given a square root of something and 4 answers, well, it's probably going to be faster just to test the answers directly. But a lot of times they'll kind of cover this up with some algebra by kind of asking you to figure out the square root of something plus something else, or do something to make it so you just can't check by squaring them directly. But that's important to eliminate answers and get down to figure out just how closely do you have to know it. Okay, so I'd be interested to know if this helped you out. Give me some feedback. If not, ask another question and we'll try to make some more of these. Thanks very much.